Hi everyone, Tarulli Tutoring here. In today's video, we're going to be tackling the concept of solving linear inequalities. So before we start going through some examples, just a little reminder that our inequalities are as follows. This symbol is less than. We have this symbol, which is greater than. We have the less than symbol with a little line underneath. This means less than or equal to. And if we have the greater than symbol with a little line underneath, this means greater than or equal to. Okay, now that we've gone through that little review, let's start with some examples. Okay, example 1. We have 2x plus 1 less than 5. We want to solve this. Okay, so what we want to do here is we actually want to isolate for x. So to do that, we're going to need to subtract 1 from both sides. Okay, when we do that, the 1 on the left side will cancel. So we have 2x is less than 5 minus 1, which is the same as saying 2x is less than 4. Now what we want to do is we want to continue to isolate for x, so we're going to divide both sides by 2. When we do that, the 2 on the left side will cancel, and saying that we have 4 over 2 is the same as just saying 2, so our solution is x is less than 2. And that's it. It's basically like solving an equation. It's just instead of an equation, we have an inequality, right? You know, we'd isolate for x in a normal equation. Just a different symbol we're using. Let's not overcomplicate things, right? Alright, let's go into a little bit more of a challenging example. Alright, let's say this is example number 2. Okay, so we have 3x plus 4 is greater than or equal to 5x plus 2. Okay, so this is a little more complex because we have x on both sides of the equation. But same thing, we still want to isolate for x, right? We want to isolate and solve for x. Same steps. All right, so what I'm going to do is I'm going to bring my x's, all my variables, all to the left side and bring all my constants to the right side. You could do it the other way around, doesn't matter, as long as you keep things consistent. But that's how I'm going to do it. So I'm going to say 3x minus 5x, because I'm going to subtract 5x from both sides. Right, that'll cancel the 5x on the right. And then I have plus 4 greater than or equal to 2. Okay, now I want to bring over my constants, again, all to the right side. So I'm going to subtract 4 from both sides. Right, that'll cancel the 4's on the left. So I have 3x minus 5x is greater than or equal to 2 minus 4. Okay, now I'm going to simplify both of these. 3x minus 5x is negative 2x, greater than or equal to negative 2. Okay, so what I want to do here is the same as last time. I'm going to divide by the coefficient, so I'm going to divide by negative 2. However, when I do this, there's one thing I need to take into consideration that is different from if this were an equal sign. If this were an equal sign instead of an inequality, I wouldn't have to worry about this rule, but it's not an equal sign. It's a greater than or equal to symbol. It's an inequality. So when I divide or multiply by a negative number and I have an inequality in my statement, I need to switch the inequality. So I'm going to write that out because it's very important. When dividing or multiplying by an inequality, switch the inequality. Now, what I mean by switch the inequality is if I'm using a greater than symbol, I'm going to swap it to a less than symbol. If I'm using a less than symbol, I'm going to swap it to a greater than symbol. If I'm using a greater than or equal to symbol, I'm going to swap it to a less than or equal to symbol. Using a less than or equal to symbol, I'm going to swap it to a greater than or equal to symbol. Right, I'm going to change it to the opposite thing. Okay, so in this case, I am using a greater than or equal to symbol. So I'm going to swap it to a less than or equal to symbol, which gives me x is less than or equal to 1. And that will be my solution to this inequality. Okay, I can represent this on a number line if I want. I can draw a little number line. And because this is inclusive, because it's less than or equal to, I would put a 1 here and say that my solution is from all of these numbers from negative infinity all the way to 1. There's nothing on the other part of the number line because it has to be less than or equal to 1. But those are all the solutions I have. Okay, moving on to our third example. Scrolling down a little bit to make some room. We have a double inequality. So we have 5 is less than or equal to 2x plus 1, which is less than 9. Okay, so when I'm dealing with this sort of thing, I am going to want to apply the same techniques I've done before, except I'm going to still want to isolate for x. It's just I need to be a little more careful because I have 2 inequalities I'm dealing with. So again, I want to get rid of this constant that's being added, this 1, so I'm going to want to subtract it. But instead of just subtracting it from one side, I'm going to subtract it from both sides of my inequality. So we'll say minus 1, minus 1, minus 1. So I get 5 minus 1, less than or equal to 2x. These cancel. 9 minus 1. If I simplify that, I get 4 is less than 2x, less than 8. Okay, so now I'm going to want to divide out this coefficient of 2, and I'm going to divide, on my right side and then on my left side as well. So go ahead and do this. When I do this, I get 2 is less than x, less than 4. Okay, again, I can represent the solution on my number line, right? This is the final solution, and I can put this on a number line if I want. You don't have to, depends on what your teacher requires. Okay, so basically what I'm saying with this statement is that my solution is between 2 and 4. And again, I'm using a little open circle because it's not inclusive, it's not equal to 2, and it's not equal to 4. So my solution is going to be between this range. Again, not equal to either of the numbers, but it's all the numbers in between there. So 3 could be in my solution set. Could have 2.5, 3.5, and whatnot, right? Any of the numbers between 2 and 4, but not including 2 and 4. And that concludes this video. I hope this was helpful. If you have any questions about inequalities or solving linear inequalities, please feel free to drop them down below. And if this video was helpful, please give a like and a subscribe, and I would really appreciate that. Thanks so much.